Imagine a world where AI models can see the world like humans do. Our next speaker, Sanja, will explore the process behind unleashing the power of computer vision. She is a Bay Area based expert with 15 plus years of experience in computer vision, machine learning, and signal processing. Holding a PhD in electrical engineering, she specializes in algorithm development for computer vision. Let's buckle up for computer vision demystified from segmentation to image generation. Please welcome Sanja Damjanovic.
Hello, everyone. My name is Sanja Damjanovic. This is my LinkedIn profile. Please feel free to connect. And as a professor, my passion is teaching. And for today, I'm prepared to take you for a journey from segmentation to image generation, the journey of computer vision. So let's start with fundamentals. So what is the connection between computer vision and artificial intelligence? And what is artificial intelligence? Artificial intelligence tries to emulate the human mind and human cognitive abilities such as learning new information, finding patterns in big data, and solving complex problems. It's a very wide field, and subfield of artificial intelligence is machine learning that uses complex algorithms to solve problems and to extract information from large data sets. Subfield of machine learning is deep learning that uses deep neural networks and neural to find information from big data sets. And as next step in the development of algorithms is generative AI that is capable of generating content, visual, speech, or multimedia content by using even more complex techniques such as attention mechanism and transformers. Computer vision is area of applications of all these techniques that use visual information as input. Of course, there was a computer vision even before. Computer vision exists also outside AI, and where the exact techniques are used from the classical physics or signal processing alike. So let's start from the very beginning. The fundamental visual information is contained within the image. And what is a digital image? So it is a grid of pixels. And pixels are numbers with values from 0 to 155 that represent the amount of light in that pixel. So 0 represents the absence of light, and that's black color, whereas 255 is the highest amount of light and represents white pixel. All the values in between are in gray valued, and the combination of different spatial values of these values represent the image. So different local variations of pixel values and intensities present different objects. So here we have different different images that represent, for instance, grass, beach sand, and brick wall that have a common name. And as you saw it's texture. So different local variations represent different textures. For variations, high local variations, we say that the region is highly textured, whereas for uniform regions, we say that those regions are low textured or textureless. And that's how we describe the regions of the image. So based on analysis of those numbers, we can perform different computer vision tasks. And one of the computer vision tasks is object detection. What does it mean to detect an object in the image? And it means that we have found the exactly position of the image of the shown object, as well as we identify the category or class that that object belongs to. How does computer vision algorithm know how to draw these bounding boxes? Well, as humans, it learned it. So computer vision model has been trained on on a big data set that contained the given images with all annotations and ground truths. So in the process of training, all coefficients of the convolutional neural network in this case have been learned. And after this training step, the model is capable of identifying new unseen objects that belong to the classes it was trained on. So here, the objects are, so the position of the object is denoted by the bounding box that is actually whose position is the result of the regression training, as the bounding box is defined by its center, position of its center in the image, and its dimensions. So those are 4 numbers. And by the class, that is classification task, that gives the type of the object shown in the bounding box. And you can, after the training, the model has been trained. The coefficients are, you can use coefficients to do the inference on new unseen images out of the box. So this is example on one image that was not in the data set, and we see that the algorithm detected and draw bounding boxes around objects that are persons and cars, and those were identified good. However, the bicycle is detected as motorcycle. That is obviously erroneous. However, the angle of this bicycle was not ideal, so that's why probably this mistake happened. Also, scooter is not identified, as the training of this YOLO model was done on a data set that did not have a scooter in its data set. So it was not possible to detect something that the model did not learn. Another computer vision task is classification. Classification identifies object, the class to which object in the image belongs to. So in this case, it's a cat. It's cat, class of the cat. So there could be even multiple objects in the image, and yeah, their classes could be given. Next computer vision task is image segmentation. So there are different types of image segmentation, and in the case when each pixel of the image is classified and labeled, for instance, with the colors to which class it belongs to, it's semantic segmentation. Whereas in instance segmentation, we have instances, we can distinguish between instances of the same class. There's also a third type of segmentation that combines both of these types of segmentation, and that's called panoptic segmentation. And then it classifies both and pixels and distinguishes between different instances of the same class. And here are some resources if you that are open source if you wish to try out inference for yourself or to start learning computer vision. So what is very important is accessibility to data sets, models, and programming libraries. And here are some of the resources, so open source resources, sites that you can start with. So OpenCV is image processing library initially that is extended also to deep learning. Then Hugging Face is a well-known AI company that also has open source part with computer vision models. And then RoboFlow and Ultralytics are exclusively computer vision companies that also host open data sets and libraries for different computer vision tasks, and Voxel 51 as well. So in next development of computer vision, so what happened is that if there is a system that's contains both computer vision capabilities and large language model capabilities, it can describe the content of the image. As large language models are capable of generating human-like text output and also answering the text prompt. and computer vision provides the visual context of the information. So training together a system, an AI system that in the training process connects the images with its captions. So enables that in the step of inference, large language model can describe the content of the image. Large language models are so-called foundational models, as they are trained on huge amount of data that is generalistic. So there is no specific task they are trained of, whereas computer vision models mentioned previously had specific computer vision tasks that were trained on. So such tasks besides classification, object detection, are also, for instance, image captioning, could be face detection, anomaly detection, or tracking, or action recognition. And large language models also make possible that information, automate visual search within visual information, and can provide information and description of the information that is to be found in, for instance, video content. Generative AI also makes possible visual search, like here example in Google Lens, visual search engine that is powered by generative AI. So in this use case, it is possible that based on image, and thanks to image to text technology, user can perform search only based on image, where the computer vision provides visual context, so it can detect objects in the image context and also text using optical character recognition technology. So in Google Lens, based on the input, for instance, this is image of textbook, it is possible to extract text from the image and create notes. Then it can be used for translation, automatic translation in different images. And also this technology is suitable in being included in different accessibility tools for visually impaired persons. Recently, there is multi-search available where visual information, so image can be combined with text for multimodal search. Generative, so here are examples of several generative AI models that can generate images based on the textual prompt. And here I give example of DALL-E 3 Imagen. So DALL-E 3 is from OpenAI. Imagen is created in Google, and Stable Diffusion is created by a company Stable AI, and it's open source model. So these generative AI models open a lot of capabilities for application in computer vision tasks, such as they can improve the image quality. So it opens the door of improving quality of computer vision data sets, as they can remove noise or remove certain unwanted objects present in the image, or enlarge image, increase its resolution, and so on. That is very convenient, as in that way we increase the quality of data set, that increases the accuracy of the models. Next, as it can generate really realistic images, and not only images but also videos or 3D models. This can help in visualization and analysis of different non-existent objects that can be grasped better and analyzed, and also, as mentioned, example using digital twins. Next, new images, new synthetic images. Yes, please.
For example, if you are getting a lot of data from some factory processes, and if you want to clean up all the images, like of some disturbances, maybe, is there a tool where you can, remove, like as you said, remove unwanted portions of images on a large scale?
Yeah, generative. So this generative model, you can use them to, let's say, increase quality of the images you have, or increase the. It's possible, let's say, to perform automatic restoration of the images if you have damaged photograph, old photography, it's like restored to look as if it's new, or it can be, the content of the image can be enlarged, so filled out of its boundaries and so on. But of course, these technologies have some issues that one must be aware of, like a diversity of data bias in the data sets and the propagation of already generated content, so that feedback loop. So this is this was just a quick overview of the way computer vision has passed only in the last decade. So, and I'm excited to see what the next year or two will bring. So computer vision is about teaching machines to see, and also is expanding the horizons and the meaning of perception.